Define key features of exponential function. Let's say here is what are the key features of each function, but we have just one function here. So is a 5 in 5 times 1 over 2 in exponent x. So include domain range, include the domain range, intercepts, asymptotes, and the end behaviors. So first of all, let plug in the values of y here in this table. So to find the values, first of all, we are taking this g of minus 2. And g of minus 2 here is a 5, and instead of the x here, I'm plugging a minus 2. If I'm plugging here minus 2 everything, what is going to happen here is going to be 5, and this is going to be 1 in minus 1 and 2 in minus 2. But for us here, to make this positive exponent, we are going to take the reciprocal of this value here. So we have so is 2 square positive over 1. But 1 in square in minus 2 is in 1 in square is 1, so is just 1. And now here we are going very quickly. 2 square is 4 times 5 is 20. So this is 20, positive 20. If I'm taking a minus 1, g of minus 1, so let's find those value. If it's a g minus 1, here is a 5 times 1 over 2 and minus 1. So same thing happened like in the first scenario, but in this case, for example, is going to be 5 times 2 in positive 1. I'm sorry about this. So it's a positive 1. Is a 2 in 1 divided by 1, which is 2 in 1 is a 2 times 5 is a 10. So this value here is a 10, positive 10. So if we are plugging here g of 0, and here is a 5, and 1 over 2 in a 0, this one is going to be 1 over 2 in a 0 is 1, times 5 is a 5. So this value is a 5. And 5 in 1, g in 1 is going to be this way. So it's a 5 times 1 over 2. In 1 is everything 1, so is a 5 over 2. So this is a 5 over 2 or 2.5. So I can write 2.5. So if we are taking now this value, for example, g of 2, what's going to happen here is a 5 times 1 over 2 square, and this one is a 5 times 1, 2 square is 4, and here is 2 is a 4, and a 5 over 4. So this one 5 over 4 is a 1 point something, 1.25, or but let's write as a fraction 5 over 5 over 4. Okay, so let me erase this thing here. Let me write quickly. Is a 5 over 4. So those are the values. If we are plugging here, let's say here is a minus 1, minus 2, here is 1, here is 2. But those numbers here is not in the scale. I'm not trying to do in the scale. In the scale. So in a minus 2 is going to be 20. So here is a somewhere. Let's say here is 20 somewhere. Okay. Let's say here is a 20. 20. Let's say here is a 10. And let's say here is a 5. Okay. So what is going here to be this function? 1 and 5. The other point is here. 1 is a 5 and 0. 0 and 5 is here, minus 1 and 10, minus 2 and 20. And now what do we have? We have a 1 and 2.5. So 2.5 is here somewhere, let's say in the middle, 2.5. And this is 5 over 4 is here somewhere. So if we are connecting those lines now, let's say those lines are going to be something like this. So this is the graph of the function. This is how it's going to look, this function. And what do we have here? Domain. What is the domain of the function? Well, domain of the function is from minus infinity to infinity. So the domain, let me write the domain, is from minus infinity to infinity. If we are looking here for the range of the function, what is the range? The range of the function is from 0 to positive infinity. So is from 0, but 0 is not included, so that's why we are taking making here this is a parentheses, so it's not included. It's from 0 to positive infinity, the range. And intercepts, we have just a y-intercept, and a y-intercept is y is equal with 5. X-intercept does not exist. X-intercept does not exist. And what do we have? Asymptote. Asymptote is, let me say, asymptote is y is equal with 0. So here is y is equal with 0 is a horizontal asymptote. So the function is not going to intercept the x-axis nowhere. So it means that the y equal with 0 is asymptote. So we have a horizontal asymptote. So let me write horizontal asymptote with the HA. And end behaviors of the function. End behaviors are this way. As the x goes to infinity, positive infinity, y approaches 0. And what do we have else? And as the x approaches to negative infinity, as x, let me write here, as x approaches to negative infinity, y approaches a positive infinity. So those are the end behaviors of this function.